How do photons create electricity in solar cells? Imagine sunlight hitting a surface and turning into usable power. That's what happens inside a solar cell. When sunlight reaches a solar panel, it is made up of tiny packets of energy called photons. These photons carry energy from the sun and are the key to generating electricity. Inside the solar cell, which is usually made from silicon, these photons are absorbed when they hit the material. For a photon to be absorbed, it must have enough energy, at least about 1.1 electron volts, matching the energy needed to excite electrons in silicon. When this happens, the photon transfers its energy to an electron in the silicon, giving it a boost. This causes the electron to jump from its usual position, called the valence band, to a higher energy level known as the conduction band. This movement creates what is called an electron-hole pair. The electron is now free to move around, carrying a negative charge, while the hole is the absence of an electron and acts like a positive charge. But just creating these pairs isn't enough to generate power. They need to be separated and directed to flow through an external circuit. This is where the p-n junction inside the solar cell comes into play. The p-n junction is formed by joining p-type, positive, and n-type, negative, silicon layers. This junction creates an electric field that pushes electrons toward the n-type side and holes toward the p-type side. This separation of charges is essential because it prevents the electrons and holes from recombining. As the electrons move through the external circuit from the n-type side back to the p-type side, they produce an electric current. This flow of electrons through the circuit is what we use as electricity to power homes, businesses, and devices. Meanwhile, the holes move internally toward the p-type side, completing the circuit. Not all photons generate electricity. Some pass through the silicon without being absorbed, especially if their energy is too low. Others with very high energy lose some of that energy as heat, which is a loss in efficiency. To maximize absorption, solar panels are designed with anti-reflective coatings and textured surfaces that trap more sunlight. In real-world applications, many solar cells are connected together into modules and arrays to produce enough power for large-scale use. Engineers work constantly to improve materials and designs to make solar power more efficient, affordable, and reliable. So, in simple terms, photons from sunlight excite electrons in silicon, creating charge pairs. The electric field inside the solar cell then separates these charges, causing a flow of electricity that we can use to power our world.